Good day, everyone. Good day, sir. I am Jemerson John D. Nakwa, and my partner is.
Remy Gabriel Cordero.
And today we're gonna demonstrate our airplane light controller, ALC for short, and it is implemented using Verilog HDL and deployed on the Intel D10 Lite FPGA board, which is what we are using right now. So the system uses a finite state machine to control the no electronics and seatbelt indicators based on aircraft altitude and flight conditions. So before we start the demo, we will identify first the physical switch mapping on the FPGA board. So switch 9 corresponds to N reset. Our switch 2 corresponds to turbulence. Our switch 1 corresponds to descending. Our switch 0 corresponds to climbing. Our switch 8 corresponds to alt 25K or altitude 25K. And our switch 7 corresponds to alt 10K or altitude 10K. So the output signals are displayed using LEDs. So the first one is our no electronics. The second one is our seat belt. And the third one is our smooth. So with this mapping established, we will now demonstrate the system behavior.
Okay, so Remy here now. So I will now do the demonstration for the ALC. So let's start. Right now we're on the ground. All three lights are on. It's smooth. You need to have your seatbelt fastened, and you're not allowed to use electronics. So let's say we start ascending to 10K. So let's set the 10K switch. Make sure it's fully pushed up, and let's ascend. Once that's done, turn that off. Make sure it's off, and as you can see, the no electronics light has extinguished, but the seatbelt light and smooth light remains on. You may have also noticed that during the ascent phase, the smooth light was also off. So let's say that while we're still in this holding altitude, we experience some turbulence. So turn on turbulence switch, and as you can see, the smooth light switch has extinguished, but the seatbelt light remains on. Turn that off, it's still the same. When does the seatbelt light turn off? Well, to do that, let's ascend to 25K. Make sure only a 25K switch is pushed up, and let's ascend. As you can see, we are now at above flight level 250 or above 25,000 feet. So let's turn that switch off just to be sure. And as you can see, only the the smooth light is on. If we have turbulence, the seatbelt light will come back on and the smooth light will turn off. But turn that off and it will go back to smooth light. Now, let's start descending. So let's descend from 25K. Make sure only 25K switch is pushed up, and let's descend. On descent, as you can see, smooth light comes back on. We now have a seatbelt light on. Let's turn off the 25K switch, and let's turn on a 10K switch as we want to descend below 10K. Turn that on, and let's descend. As you can see, smooth light went out. Seatbelt and electronics are back on. Let's stop descending. So I don't know, we probably landed now. So we now have the seatbelt light on, the no electronics light on, and the smooth light back on. Maybe there's turbulence during landing, so that also works. One more thing. Let's say that you are kind of lost on the state of the machine. One thing you can do is use the N reset. N reset requires that this switch be at 0 for it to trigger. Then once you're done resetting it, you push it back up, and everything's back to ground state, where we're basically below 10K.
So in conclusion, we successfully implemented an finite state machine based airplane light controller using Verilog HDL, verified through simulation and synthesized in Quartus, and is deployed on this board. So the design correctly tracks altitude, detects smooth light, and controls the no electronics and seatbelt indicators according to the specifications. That's all. Thank you.